Okay, so physicists have been waiting for this for ages, like, since 1916. It's a major deal because it gives us a peek at one of the universe's craziest things, black holes. These things are super strong but hard to see, which makes them extra mysterious. There's this one black hole that might be the thing we're looking at now. It's probably like 2 to 4 million times bigger than our sun. Before now, we barely knew anything about black holes, but now we're starting to get a good look at them. And get this, a physicist named Michio Kaku says we've actually seen inside a black hole. This could give us tons of new info and change what we think we know about science. So, let's talk about black holes. Space is huge, but black holes bring up a lot of questions. Before we get into Kaku's findings, it's good to know the basics. Most people know what black holes are, but there's still a lot we don't know. The idea of black holes goes way back to 1916 when Einstein came up with his theory of relativity. It said black holes could exist, but it was just a theory. Then, like 50 years later, in the 60s, we started finding proof. Researchers saw this bright star that was sending out X-rays. It was going around something big and dark. They figured out the X-rays were being pulled into this object, and that's how the name black hole came about. It was a big moment because it showed black holes weren't just in Einstein's head, they were real. So, scientists started studying this black hole in the Cygnus group, called Cygnus X1. It's about 6,000 light-years away and super bright, like 14 times brighter than the sun. It's also really dense and has so much gravity that not even light can get away. That's what makes a black hole, it traps light. Black holes are both cool and scary. If you get too close, you're sucked in and gone forever. That's why it's important to learn more about them. After finding Cygnus X1, people started looking for more, and now they think there might be over 100 million black holes in our galaxy. But they're hard to find, so we don't know for sure. What we do know is there are probably millions out there, which means they're important to study. The main worry with black holes is their gravity. It's so strong that anything that gets close gets squished into a tiny point. They're like cosmic vacuum cleaners, sucking everything in. If you fell into one, you'd get stretched out really long because of the gravity. And you'd die before you even got close to the end of it. So, yeah, don't fall into one if you can help it. Even though the closest black hole is 500 light-years away, it still makes you wonder if they could be risky to us. In 2021, scientists took the first actual picture of a black hole. It was in the M87 galaxy. They took a bunch of pictures and put them together to get a good look. It turns out a black hole isn't just empty space. It has 3 parts. First, there's the event horizon. Once you cross that, you're done for. Second, there's the photon sphere, where light gets stuck orbiting the black hole. And third, there's the singularity, where everything gets crushed down to a tiny point. That's where the rules of physics stop making sense. What's also crazy is that every black hole is a little different. They all have those 3 parts, but they act in different ways. Usually, scientists use telescopes to look at stuff in space, but you can't do that with black holes because they're invisible. You have to watch the stuff around them, like the light and gas. And you can't send probes to check them out because they just get sucked in. So, scientists have to study them in sort of an indirect way. One idea about how black holes form is that they're made when stars collapse. When a star runs out of gas, it can't fight against gravity anymore, so it collapses and can create a black hole. To learn more, NASA looked at the center of the M87 galaxy. They saw this huge swirl of hot gas going super fast. It should have flown apart, but it didn't. Scientists think a big thing at the center, like a black hole, was holding it together. The black hole would have to weigh like 2 to 3 billion times more than the sun. But black holes might not just come from stars collapsing. This mathematician, Roy Kerr, used Einstein's math to show that a spinning black hole would form a disk instead of a point. That disk is called the ergosphere, and it's a place where the rules of physics get weird. Kerr's math also said there could be a wormhole, which is like a tunnel that connects 2 different places in space, or even 2 different universes. So, if you fell into a black hole, you might go through a wormhole and end up somewhere else. To get how a wormhole works, you need to understand space. Einstein said space and time are connected. Things with mass bend space, which creates gravity. Think of space as a piece of paper. If you put two dots on it and draw a line between them, that's how things move through space. But if you fold the paper, you can make a shortcut between the dots. That's like a wormhole. Wormholes aren't just in movies. They're what Einstein's theory said could happen. But nobody's seen one yet, and they're probably not stable. They'd probably collapse right away. Still, the idea of using wormholes to travel through time and space is cool. The thing is, Einstein said nothing can go faster than light, so wormhole travel might not be possible. One kind of wormhole, called the ER wormhole, has gotten a lot of attention. It could connect two faraway places, maybe even different universes or different times. But some people think it's unstable or that you couldn't travel through it because of all the radiation. Some physicists say Einstein's math doesn't take into account the small stuff, like atoms. To really get black holes and wormholes, we need a new theory that combines the big stuff with the small stuff. That's called a theory of everything. Michio Kaku has been working on this theory for years. One idea is string theory, which says everything is made of tiny vibrating strings. So, the universe is like a song, and different particles are different notes. String theory might explain black holes and wormholes, too. Even though it sounds good, string theory is just an idea. It says there are extra dimensions that we can't see. They might be really small. Some people think they were bigger at the beginning of the universe and then shrunk down. String theory could explain a lot, but it's still just a theory. As we learn more about space and black holes, there's definitely more to find out. We've only just started to understand black holes. Kaku's work on string theory is just a start. We have better pictures of black holes now, but there's still so much we don't know. The study of black holes is still a work in progress with lots of thinking and exploring to do.